how are you? So, welcome back to this IoT on Cloud Part 2. If you join us for the first part, well, let me thank you for being here again. And if you're just joining for this part 2, don't worry, I will do a little recap. Plus, in the first part, it took us a lot of uh, trouble to configure the Node MCU board. So I do a little bit more of research and stuff, and I have it working right now. Like I have it connected to the computer, and now we're going to focus more not on the setup and stuff, but in the writing the code for this to work as we want to. Right. So yesterday we made all the downloads and the configurations and stuff, but we ran to an error that the board wasn't connecting to the MCU and Node MCU tool, so we couldn't upload our code. Right. Right now, here's the screen. Let me change here. Come on. Okay, it's added now. So here's the screen, and we can connect our board. I'm thinking that maybe this time, again, trying to um, show you how this works on QuickTime file, new mode recording. Okay, here we have it. So don't know why. Okay, again, let me. I'll put these here, and just give me a second. I'll make these. As large as I can. I'll close this and I'll come here. So um, here, let me clean the camera. Here we have this, right? We have it here, and right now I have this simple test program that just indicates that the LED on number 8 pin, that if we remember was this one, um, number 8, number 8. Oh, there was a table. I need to check it again. Um, oh my god. There was a table for the pin references. Um, okay, I'll have to find the table again. I can close the build firmware. I'm flashing the firmware, uploading the code. We already covered and mastered these. Reference pinout. I think it was, well, that's Node MCU. Um, Pinout reference. I'm typing with just one hand, so. Oh my god. Node MCU Pinout. Yeah, here the number 8. It was a table. I cannot remember where it was. I need to find it now. Sorry. Ha ha ha. Okay, here. It was something like this, but I thought it was here somewhere. Programming in Node MCU. I think it was here. It has to be a table. Language reference. Manual language reference, maybe. Oh my god, no. Basic complex, basic concept, language, application, system. Well, we will stick with this then. Um, the point is that I have this on the GPIO. I think it's the 10, maybe. Let me check. Well, we can see together. Here it was. The LED is on pin D8. Yeah, so D8 is GPIO 15. 15. So 15 will be D8. Yeah. Well, well, the point is here the value of 8. It's for the LED, the blue LED we have here. So we can now go to developer IoT, and here we're going to run node MCU, upload the LED file. It was uploaded correctly, and if we not run, but sorry, not upload but run, it starts, right? So let's make the changes now for these to activate when the buttons are pressed. So we're going to do the readings for LED 1 being 6 and LED 2 being 8. The button will be on input 11. Let's change that then to be on 0 and 1. Well, 1 and 2. And let's see if that fits with this table. D1 it's 5 and D2 it's 4. So this doesn't make sense. Oh my god. Um, this is why it's weird having to GPIO 5 and GPIO 6. But the values of these I need to put, that's the one I want. Now I'm all confused about this. Let's start looking for that. it was stable, and I thought it was here on the overview, well, in the documentation. Okay, I'm going to look for the module. Maybe it is there. GPIO module. Yeah, here it is. Oh my god, how hard. One, it's for GPIO 5. Two, it's for GPIO 4. So amazing. One and two, great. Huh, hard to find. So GPIO 5, it's the GPIO 5. Well, we can close this now. GPIO 5, it's the one. So we're going to change this here to the one, and GPIO 2, it's GPIO 4, it's the 2, I want to say. So that will be button 2 according to this table. Yeah, cool. And now we make the changes. We need to check the documentation of this again because we need to set the mode, and the pull up GPIO pull up enables the weak pull up resistor. Default it's GPIO float. So according to this, the button should be an input, the button 2 should be an input, LED 1 should be an output, LED 2 should be an output. I want to make an experiment here, and I want to set one of these to blink. Um, but for that, maybe I'll add something that it's called blink, and that will be 0. 0, it's going to be GPIO 16, which is the 0. I'll add a LED for that, and that will be directly connected to the output to the ground. From the output to the ground. Yeah, nice. And with that, link would set GPIO mode, mode, I mean, link to set GPIO output, and write when I want to write mode read write. Okay, let's check the mode. Output open drain, input int interrupt mode. Example output. See also write. Okay. GPIO dot write and the level. Level could be high or low. Example, this one is the basic it took to this. Okay, interesting. Tool. If I read 0 and number 0, okay. If this blink it's equal 0, then GPIO right link it's going to be high, else it's going to be low. Nice. So let's return to our previous setup. This is going to look like this. Let's upload io.lua, which is this file. It's uploaded, and let's run it. Okay, this one it's blinking, but this one I don't get it. Like, why are these? Okay, this is weird. Actually, we don't need, yeah, button and button 2. Maybe increase the time here and delete these two. And we'll do the exercise again. Upload the file. And run it. Okay, now it has more time here, but still not hearing the input. Hmm. I want to check something. Okay, if I connect it directly here, it's done. If I connect it directly here, it's done. So it's the applet. So I will add the pull drain options that we saw here in the mouth. Pull up. Yeah, the pull up. Same with this one. I will upload these. Not event checking. Oh yeah, thank you so much for reminding me that. I always forget to share that. Oh, and now I thought I didn't share the feedback on my previous stream. I'm so sorry. Um, well, here's the check-in for this. Now I'll try to remember to share the feedback for for this at the end. Thank you so much for reminding that. And yeah, now I realize that I didn't share the feedback for the actions session. So I'm sorry. I'm sorry. Okay, it is uploaded, and let's run the IO. So now, same, but the behavior changes. I hope. Okay, let me see. If this is directly connected to the voltage, it's this is connected directly to the ground. Okay, maybe I know what it's needed here, but I'll need some resistors. So give me a second. I'll take out some resistors from my box, the magic box. Okay, here they are. I will try to document everything I'm doing with this. So here we'll try to find some resistors. This one with the oh my god. Well, the color doesn't matter. Well, it does matter. Don't put that much attention. The point is, I have 303 ones here. Well, no 303, no 330. Um, and I will need a second with the two hands to connect them. Yeah, this worked better. Give me a second. I lost one of them. Okay, here they are. Yeah, so much better. This works now. Well, take a look at this. Now both are working. Um, with the pull-up configuration, what I needed is that this green cable it's passing the voltage to the button, but the signal wasn't finalizing to ground. That is what the pull-up resistors are for. So I thought that it had like internal pull-up resistors like many others, but it doesn't have. So here we connect via a resistor to the ground. So every time the button is not pressed, the resistors make the ground to make it to the ground. So when I press the button, the link the how to say it, LED stops. Oh, this one not. Actually, I'm curious about why. Okay, because it's connected wrong. It's connected to another port. Give me a second, and I'll correct that. Okay, now perfect, perfect, amazing, amazing. So let's do a little change here, um, because in code this was supposed to behave the opposite, isn't it? When it's one, when it's one, and now we can reduce here and we can delete the blinking one. Well, it doesn't matter, we can keep the blinking one. But I'll remove the physical LED since I realized that we have a blinking LED that does exactly the same of port D0 that it's integrated into the board, so no need for a physical LED. And now, here it is. Let's run the upload command again. It's uploading, and let's then run the program, and it's uploading. It's running. Okay, we see we increase the speed. So that means if you realize when I press the button, sometimes it changes, sometimes it don't, because it has to wait, or it had to wait. I mean, sorry, 500 milliseconds. This time it has to wait only 50. So changes are displayed immediately. Nice. So with this, let's start making more interesting stuff. I now want to create a server or create a Wi-Fi connection to send these values to a real-time database. So Let's do the configuration for that. And I'll remove the blinking because it's too much. Well, no, I'll keep the blinking. Okay, perfect. Perfect, perfect. Let's check together the Wi-Fi libraries for this. Okay, in the page they had an example for this. We can close this. This is for what I realized it was the issue I needed to fix. I didn't talk you about that. I'm so sorry. Um, Yesterday it wasn't working because of this, just like that, the connection delay. So we have it working right now, and what I did differently from yesterday, it's I made sure I had installed the drivers. Yesterday I was refusing to install it because I thought I had them. I don't know if that was a reason, but now just to make sure I installed the drivers, I reflashed the firmware, the one we created yesterday, the one we download from the page and receive on our mail and stuff. Um, okay, and the other thing I made is I created this file, node MCU control, in which I'm defining the baud rate, the port I'm using, and the connection delay. With just this configuration, everything should work for you too. And I'm uploading these to the repo. Actually, I haven't shared the repo. That's a good thing. I can share it right now. So here's the repo. You can see, you will be available to see all the code generated from the session here. So we can close this now since that's already covered. We are going to change from English here. And just one thing here, examples to connect to wireless connection, Wi-Fi, nice, Arduino like, HTTP server, HTTP client. Okay, which one of these can be interesting? Well, we will want a client for this. So let's see on the docs. I am debugging here. I'm trying to reach which library will be the best for you, for us. I mean, sorry. HTTP. Let's see. It is not possible to execute HTTP request using this model. What? Then what is this for? Basic HTTP client model that provides an interface to concurrent. Oh, okay. Um, yeah, but no. The one that it's mentioned here, it's net. So here we have net. Net model constant to be used in other functions, but it doesn't explain what this does. Create server. In the example here, create connection to server on receive, on connect, consent, net create server, listen. Okay, maybe creating a server will be more easier. So let's try a file with that, and then we can connect to the server via or client. Um, yeah, that will maybe a better thing. Else, I'm checking if there's another uh, platform here. Okay, here, for example, Wi-Fi. Okay, yeah, I think we should be sure that we are connected to our Wi-Fi um, before making this server. So the Wi-Fi subsystem is maintained by background task and moves around periodically. Any functions or task takes longer than 60 milliseconds. Okay. Soft access point. Okay, the function for connecting these to Wi-Fi was something like this. Wi-Fi station. Yeah, do we want? Yeah, we want a Wi-Fi station. Nice. So uh, let's do the code for that. I'm guessing if we can do it in the same code. So I'm just opening a new file. I'm doing this will be the complete service dot lua. And in here we're going to say print Wi-Fi dot get IP. Okay, that's for getting the IP. Okay, we can copy the full example. No IEL, I don't know what that's for. Set mode, Wi-Fi station, Wi-Fi station.config, SSID, and password. Let me see what my Wi-Fi SSID. Good question. Um, mm, okay, I'll try to do this on private network settings. Oh, um, okay, I will need to see some more details. Give me another second for that. I'm not sure. Someone who's more fluent with networks, I'm not sure if the SSID will do the same as the IP address. I'm completely not sure about that. Give me a second and I'll tell you. I'll just need to Google it. What? Hmm. Okay, it's in the router. Can I connect without the SSID? Let's check. Uh, Stack config. So stack config pwd. Hmm. Okay, I'll get my router SSID and I'll be back in a second. Oh my god, I think this is dump. You know what? SSID, I think it refers just to the name. What a weird thing, right? So give me a second, and I will add this as and the password to share it with my neighbors. Get IP, and that was just it. I hope so. Let's do the running of all of these again. Uh-huh. And this will be LMCU load, and this is complete service.lua. and then we have to run it, of course. And for comments, files info, run, upload, download, remove, format, opens terminal. LMCU terminal. Okay, I'm going to open a second terminal here to run the script again. Canada open board. Okay, because I think this is already here. Run complete. Service. Um, I'm trying to check the logs here. Okay. Maybe I'm missing Jack Connect. Mhm. Connect. Yeah, it was an option here for that. This one's connect. Connects to the configured app in station mode. You only ever need to call these if autoconnect was disabled. Oh no. So then no need to connect. I'm trying to search now. The problem here is that doing opening the terminal locks the connection, so I cannot connect to um, this and run the server. So I'm probably guessing this is going to. This is going to. How do I close this? Okay, nice terminal again, and in here, here's the terminal from the Lua from the Node MCU. Uh, I'm asking actually. Here I have another tab with an analyze model to say, can I open or can I run the file from the terminal, from the Node MCU terminal, inside Node MCU terminal? Can I run the file? Let's see if this is something like Linux, like ls. No. pwd. Okay, no. Will something like this works? Okay. Oh, so this is a console when I can run files, scripts from this. So if I do Wi-Fi signal station and I say these same things here, config table not found. What? Yeah, two strings. Or do I need to connect differently? Configure table containing configuration data for station. Oh, so it needs to be a table. What's a Lua table? That's the question. I'm not sure. I think it's something like this. Let me see. Like an object. Hmm. Okay, nice. Will that make sense? I hope so. Okay, and now again the get IP. Stating that header in precompiled chunk. What? Again? Okay. So I'm going to close this terminal. I'm going to try to upload this other file again. I want to see if I run this. Do I have any output of any type? Yeah, the outputs are here. I didn't realize before. Sorry. So, but the problem is that Neil and Neil are the outsource, so it's not connecting to the Wi-Fi. Why is that? Um, well, that's a 5G network. I'll try it with another one. Um, don't make fun of my names of my networks. And the password for this one will be so I'll try to do the same. Upload and run. Same. Why? I was just making sure the credentials were okay. I am going to try again here, directly passing these as values. Okay, yeah, there was network config table not found. So I'm guessing this is the way to pass it. But let's try with connect. I mean, it's supposed to work without that, but hey, it doesn't harm to try. No, again, no luck. Um, let's see what else we could do. Okay, I'll try directly with the SID. This was my configuration, but I'll try it with the SSID that appears on bottom. Hmm. Okay. I'm trying to think of another way to connect in. Okay. So this is supposed to be F3 A B 5 T B T M M M G A K A M 8. So let's try upload. Oh, I don't need to connect. We don't need to connect, so we upload it again and run. No, Neil. Huh. So let's ask Pilot how do I check my Wi-Fi SSID? Okay, let's do that. Terminal network setup 0. Yeah, this was the one I was sharing. Yeah, I'm not changing here. That's interesting. We can try that. Okay, let's try to upload that file. And now let's try to run it. TMR create, TMI create. Yeah, I'm directly copying that, and doesn't seems to be right. Yeah, copy it. Oh, I maybe do a mistake. Yeah. Oof. 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 So maybe that was my mistake after all, and we just need to do this again. No, still okay. Okay, copy and paste. Okay, upload and run. Okay, still Neil. What's happening here? Come on. Can't connect to Wi-Fi. Connect to an access point. Connect to an access point. Connect to an access point. Connect to an access point with specific MAC address. Configure station but not connect. Hmm. 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 Okay, let's do that. SSID, PWD. Maybe this way. And I'm also going to flash this, and plug it just to make sure, and run it. No, still does not connect. And am I missing something? Event callbacks. Okay, let's try one last time. That false no. Still not connecting to Wi-Fi. Um, let's delete and let's start checking with Copilot. The usage might be that the board is trying to print the IP address immediately after configuring the Wi-Fi without waiting for the connection to be established. To fix this, you can use okay, yeah, yeah, why not? And we have this now. Alarm, yeah, I knew. Huh. This shouldn't be alarm. This is I don't know why this they have this old version create alarm. Okay, transfer, run, not not working. Hmm. Wi-Fi status. Does this exist? Let's check. STA. maybe Wi-Fi dot star. Okay, Wi-Fi dot star has um, get IP. Okay, for installation. Got to connect, keep change, disconnect, get app, get index. Mm, okay, yeah, it has a status. What else? Okay, we can update this function for these other ones since that's not working. So same alarm, but the callback function received the timer. Okay. Mhm. So let's try this one. Upload. And then when we run, okay. So I think the status is one, but the timer is never called. No, what does a one means for status? That's what we question. Status. Station connecting. Okay. Yeah, so how we wait until this finished connection? Okay, so we have to see why this is closing before the connection is established and how we can prevent that, of course. Okay, I just read that this was supposed not to close, but the script was the one that has closed. So if I do node MCU slash tools and terminal, and I ask here for Wi-Fi dot sta dot status. Um, well, I want to print, of course, that Wi-Fi dot sta dot status. 5, which means 0, 1, 2, 3, 4, 5. STA got IP. What does that mean? I'm not sure. But if we got IP, so we can do the same. Um, print Wi-Fi dot SDA dot get IP. What's that mean? Okay, I can print dot print Wi-Fi dot SDA dot status bad header in precompiled chunk. Okay, let's open terminal again. Print Wi-Fi dot STA dot status, and that's 5. Now print Wi-Fi dot STA dot get IP, and I have an IP, so I'm guessing now I'm connecting to internet. That's great. I want to debug then, so if I close all of this stuff of waiting and I just simply connect, will that be enough? Like upload, or did this really make the change? And run complete. Well, it says it's trying to connect. So terminal again, print Wi-Fi .sta .get IP. Okay, I think this is not needed. So great, we move one step more. So we are connected to internet now. Now we need to connect these two with the one we had before, which is the I/O. And let's get this here. We can delete all these ones. Oh, actually, I'm going to set connect Wi-Fi dot Lua. This is supposed to store my information, right? So if I delete this and I copy this here and I don't give this this is supposed to work for you, right? So for this complete, for example, if I remove the board here, I close it, then I connect it again, I restarted the board. You didn't see it, but I unplug it again. I just want to test if I need to connect them again. So print because it was supposed to save, right? So to save the information, right, to the flash memory. So Wi-Fi dot sta dot status 5. So it's connected. So great. Uh, let's remove this. Let's get to the complete service again. So let's say, assuming that Wi-Fi connection is successful, the following needs to be executed. So these ones here, and let's start creating our Firebase database. So firebase.google.com. We can close these now. We can close these now. Let's keep open that one. Let's go to console. Come on. Let's get global hack with cloud 25. And on all the products, we are going to have now real-time database. So let's create a database. Yeah, here. Test mode. Great. So this is the URL references, right? Firebase.com/that. Let's set some rules. And okay, no worries. I want now just to test that. Let's say GitHub Copilot suggest. I will ask, I want to do a call to Firebase real-time database to test it. That command found GitHub. What's that? Oh my god. Well, it doesn't matter. I'll ask directly my Copilot here. Now I want to call to test my real-time database from Firebase. Let's start doing a terminal call. Cool. So for these, test your Firebase real-time database using terminal code, you need to have database real-time URL. I have it. Here's an example of the code. Blah blah blah. Replace with your favorite name and path to data with the path to data you want to retrieve. Um, so I want to post it. So curl post. I'm going to copy all of this and data path data to the JSON, right? So let's add these. Let's try this here. Just need to call to change. Let's call these test.json. And the name start from here. And let's try it. Okay, it returned us something. So we have a test with this. Perfect. So let's try to do the same here on the node server. Um, for that, here on the complete one, you are going to add the Firebase real-time URL, and this is going to be local. The Firebase URL, and this is going to be equal to the one which is copy. Nice. And this is going to be device.json. And the function for this is going to send um, the let's status. This is going to be this one. I have it here. Give me a second. So send light status. It's going to take the status that it reads from the LED, LED2, and the blink. Actually, the blink doesn't matter. Yeah, the blink doesn't matter. The payload, it's going to be as JSON, string JSON encode the status. HTTP post, this one's the library we needed to use. Content type, application JSON. And we send the payload. The function receives code data. If code's 0, the HTTP post fail. Data sent to Firebase and the HTTP response code. Actually, I'm thinking that maybe making the blink LED blink every time this is sent is better. So if the post fail, this is going to happen. So no, actually, we are going to write hide. So everything, if the its status is up, this is going to be high. If it fails, this is going to be low. So that I think it's better. So let's upload this to Node MCU tool. Upload complete service Lua. Okay, nice. It's uploaded. And run. Nice. uh, it's not working. So we may have some problems here that we need to start debugging, right? So uh, starting with the point that the blink LED doesn't blink anymore and the buttons doesn't work anymore. So I will do one thing and I'll return the blink to that point to see what's happening. I'm also not so sure of what happens when I have two timers. Every second. Let's do that every 5 seconds, just to make sure it's not something about the calling. Every 10 seconds, actually. Mm, the sets of the status. Just let's make sure this library is working correctly as JSON. I want to go here as JSON. As JSON, yeah. The SJSON model allows encoding to the code from JSON. Okay, yeah. SJSON encode. Okay, okay, perfect. So let's try this time with the complete Lua service. Okay, it's uploaded, and let's run that complete Lua service. Okay, now let it's thinking, and these are working as they should. Like, no, buttons and stuff stopped working. Huh. I'm curious about why. Let me flash and let me try to run it again. They are working. Buttons are working. Node MCU tool terminal. Let's see. Okay, it stopped working, but it just stopped at the second. Okay. When I open the terminal, this stops. So I'm going to open this again. If I return to the clouds, okay, we don't have requests. And for some reason, yeah, it fails. So I'm thinking that the reason it fails, it waits until this time to send let status, and something here it's broke. It's making this broke. I'll try not to read the status, but directly just send something like this, like name, age, or stuff. So I'm going to say 0 and 1 every time. I'm going to. Okay, I'll try to test this in another file, like the one we did with the um, connect to Wi-Fi Lua. So I'm going to say send HTTP dot Lua, and we are going to copy these and these. Actually, for maintaining, this should be here, same as these. And it will try to do that in the moment it opens. I'm just going to print sending to Firebase and print the Wi-Fi dot STA gate IP and status just to make sure. This is going to send these values, the encode. Let's print the payload, and then it does the HTTP post content type application type JSON. I think we had an example. Mm-hmm. No, I think we don't. HTTP post. There is no HTTP. Well, let's try to check if we're doing that HTTP call right. HTTP post. Content type. The payload. Function code data. Bring the code data. Okay, looks like it is node NTU upload HTTP Lua. And then we run it, and we have a problem here. Yeah, actually, another problem is this one. Um, we need to give time for this to make the request. Okay, but the first problem is that attempt to index global as JSON a nil value. Let's bring the status. Okay, interesting. Let's check that. Okay, this is a table. Then says Lua error HTTP attempt to index global as JSON at nil value. Again, but if I pass that directly, like here, the one we were checking was the HTTP. No, encode data table to encode. in function do file. So in examples, I want to see as JSON table returns a JSON string. What's this p call? Yeah, I want to test that. Run HTTP Lua, sending data to Firebase, then status. It's a table. Then again, in line 16. Why, why, why this is like that? Okay. Uh, let's inspect that now. Yeah, one good way to do this, it's just print the JSON. So let's upload again. And let's run it. Oh my god. I think we don't have the SJSON. Oh. I don't want to build the firmware from zero again. Just let me quickly check the cloud builder. Yeah, I didn't include the SJSON. I didn't knew it. I had to. Oh my god. Well, good recommendation. Um, let me find another alternative because we won't have time to complete that if we need to build it again. I think there's another library called CJSON. Yeah, and I'm not sure I had to include that. Yeah, there's no need to include that, I think. Maybe then CJSON. Let's see. No, steel needle. Oh my god. Um, I found solution for this about a function to encode. So let's try that. So we need to replace all of this with a function to simple JSON encode. In this case, we are going to pass the payload to be payload equals simple JSON encode. Uh, let's say local, and we need to print the result. Right, so let's upload it. Come on, we can do this. And let's run it to see if we have any problem. Nice, nice. We encoded it. Amazing. And no errors. So I'm thinking if we return here to the cloud, yeah, we have one device with LED 0. Amazing. 1 and 0. If I change this to both 0 and I run the program again, first I need to upload it, of course, and I then run it, then we have it. Okay, this is supposed to be real time, so come on. Come on. Okay, no, the values weren't updated. I don't know why is that. I run it. Okay, yeah, here it's updated, but here it has now a different. Uh, what is this? Device. Okay, well, the problem is that how we are sending this, right? Um, well, for the moment, let's not worry about that. Let's just copy our simple encode function here. Let's do the complete service. Let's change, well, let's add that here. The encoder, let's change the SJSON for simple encoder. Where else? Okay, yeah, no, now run HTTP, no, run, upload, complete service. And now let's run the complete service. Great. So I want to come here. Oh no, it stopped. Oh no, it do it right. So I'm not pressing any button right now. So the next one appearing here should be one with. Okay, what's happening? Oh my god. Yeah, I didn't change this. Um, so the thing I should do right here it's the read LED and read LED 2. Yeah, right. Yeah, my bad. I'm so sorry. Upload service again. So seems to be working here. The new one should be 01. Well, yeah. Now it should be 00. I'm not pressing anything. Nice. And now 01 because I'm pressing the other button. Great. 01. Perfect. So I will now just show these on the how this is working on the mobile cell phone for you, and that will be it. Let me refresh this. I will delete all this data. It should be a way in which we can keep this one with just one value. I for sure know that. For the time, I won't be doing that right now, but I just want you to take a look to this working in real life, and that'll be all for the session. We managed to complete our connection. We should be so proud of ourselves. Nice. So this is the device here. We'll make this right this the movie recording like this, and I just need this other part to start running the program, and then we can come back here, then we can come back here. So 00 should appear over the real-time database since I'm not pressing any button. Nice. It appears 00. We can change the speedness of the connection. Remember, we give around 10, like 10 seconds. I'm pressing one button, so the next one appearing will be uh, 01. This one right here, it's going to be 00 since I did was not pressing. This one right here, it's 01. And now I'm pressing the other button. Okay, well, I don't know if that. Okay, no reading this time, but now I'm pressing the red one. So left one should be one, and the red two should be 0. Perfect. So I'm going to press the two of them, and the next one appearing, it's going to be 1 1. That's it. That is just it. So I'm going to stop the program right now. And since we didn't have enough time to make this work with a dashboard, but hey, that's just regular programming. You already know that. It's just reading information from a database. The complicated part was managing to get this working, and we accomplished that. So that's it. I'm happy about it. Thank you so much for joining. And I just need to share this link with you, which is mlh.link slash global hack week feedback, please. We love all your comments. Let us know what you think about the session and if we can do something to improve. Uh, it was my pleasure to be with you this, well, for me, it's night. So I tried to hurry up as much as I could, and we managed to complete a small part of the project, but the important part, right? So thanks a lot, and I'll see you around in another Global Hack Week since this one it's already finishing. The only streams that come next are the Discover 3 ways to run your app in Cloud Part 3 with Sucker, and tomorrow closing ceremony with Cecilia and Mary. So thank you so much for joining. See you.